Hi dear students, now I am going to talk about equivalent weight of oxidizing and reducing agent. This is a 12th part of the chapter, some basic concepts of chemistry. This is the final part also, right? Equivalent weight of oxidizing agent or reducing agent students, n factor or valency factor, when n factor or valency factor for oxidizing or reducing agent is the number of moles of electrons transferred. The number of moles of electrons transferred. Students, if it is a oxidizing agent, I am representing with the O dot A. Oxidizing agent, generally it will undergo reduction. It will undergo reduction. That means reduction is a gain of electrons. Gain of electrons is called as a reduction. Whereas a reducing agent, it will undergo oxidation. That is loss of electrons. Loss of electrons is oxidation. For example, if you take a zinc reaction with the Cu2 plus ions, zinc solid reaction with the Cu2 plus aqueous solution gives rise to Zn2 plus aqueous plus Cu solid, right? Here oxidation state of zinc, elemental state oxidation state is 0. For the copper 2 plus ion, oxidation state is same as a charge on the ion plus 2. Copper, it is elemental state, oxidation state is 0. For Zn2 plus, oxidation state is same as a charge, that is plus 2. For zinc, there is a increase in oxidation state, right? Increase in oxidation state is called as oxidation it is, right? So by losing 2 electrons, Zn0 elemental state, it is converting into Zn2 plus ion. Whereas for the Cu2 plus, that Cu2 plus, it is converting into Cu0 by gaining 2 electrons. Gain of electrons is called as reduction, right? So here in this reaction, the reactant which itself it is undergoing oxidation is called as reducing agent. Zn, zinc is a reducing agent. The reactant which is undergoing reduction, that is called as a oxidizing agent, right? Equivalent weight of oxidizing or reducing agent is equal to molecular weight divided by n factor. Students, just now we discussed that the n factor for oxidizing or reducing agent is a number of moles of electrons transferred, right? Oxidizing agent will gain the electrons, reducing agent will loses the electrons. Let us take some examples. Potassium permanganate, we know it can act as oxidizing agent in all the mediums, right? So ionic form of the potassium permanganate, we can write it as MnO4 minus, permanganate ion. In the acidic medium, permanganate ion, it is converting into Mn2 plus. Mn2 plus. If the molecular weight of potassium permanganate, is M, then its equivalent weight is equal to molecular weight divided by n factor. Molecular weight divided by n factor. Here the oxidation state of Mn is +7. +7 is converting into +2. Right? Number of electrons gained by the oxidizing agent is 5. Right? Number of electrons gained, it is 5 electrons. If it is a 1 mole of MnO4 minus, 5 moles of electrons it is gaining. That is same as a n factor. So the equivalent weight is equal to M divided by 5. Right? So same permanganate in strongly alkaline medium, it will convert into manganate, MnO4 2 minus. MnO4 minus is called as permanganate, MnO4 2 minus is called as a manganate. So Mn oxidation state in permanganate is +7, Mn oxidation state in manganate is +6. This is in the strongly alkaline medium, strongly OH minus alkaline medium. So +7 it is converting into +6 means number of electrons gained is only 1 electron per ion. If it is 1 mole of electrons it is gaining. So equivalent weight is equal to molecular weight divided by n factor. Here it is 1. In the neutral medium, MnO4 minus, in the neutral medium or faintly alkaline medium, MnO4 minus will convert into MnO2. So +7 it is converting into the +4 oxidation state. The number of electrons gained per ion, that is +7 when it is converting into +4, the number of electrons gained is 3 electrons. For 1 mole of MnO4 minus, that is 3 moles of electrons. So the equivalent weight is equal to molecular mass is M divided by n factor is 3. Let us take some more examples for this. Dear students, we will take one more example. K2Cr2O7, potassium dichromate, can act as oxidizing agent only in the acidic medium. Ionic form we can write it as Cr2O7 2 minus. In the acidic medium, it can act as oxidizing agent which convert into 2Cr3 plus. For 2 chromium atoms, oxidation state is +12. On the product side, oxidation state for 2 chromium atoms is +6. Right? So the number of electrons gained is 6 electrons. Oxidizing agent will gain the electrons. Then equivalent weight is equal to, if the molecular weight is M divided by n factor is 6. Right? Similarly, we will take FeC2O4, ferrous oxalate. FeC2O4. Oxidation state of Fe is +2, ferrous oxalate. Right? Then oxidation state of oxygen, common oxidation state is -2. 4 oxygens are there. So for 4 oxygens -8. Then for 2 carbon atoms, oxidation state is +6. 2 carbon atoms, oxidation state is +6. So here Fe+2 is oxidized into Fe+3. Number of electrons lost, that is 1 electron, -1 electron. Fe+2 is converted into Fe+3. Meanwhile, C2O4 2 minus, oxalate ion is oxidized into carbon dioxide, CO2. The number of carbon atoms we can equate by putting the coefficient of CO2 as 2, right? For 1 carbon, here two oxygens are there in the molecule, right? So 2 oxygens, so minus 4, that is for 2 oxygens in the one CO2 molecule. Then for 2 molecules of CO2, that O2 oxidation state will be minus 8. Then for the 2 carbons, oxidation state is plus 8, right? So plus 6, it is converting into the plus 8. Number of electrons lost by the carbon atoms in per one molecule of ferrous oxalate is 2 electrons, right? So then here the N factor for ferrous oxalate will be 3, it is, right? In the same molecule, one element Fe is converting from plus 2 to plus 3 and carbon plus 6 to plus 8. So here the equivalent weight of ferrous oxalate is molecular weight divided by N factor is 3, right? Sodium thiosulfate we will take Na2S2O3 plus I2 gives rise to NaI plus Na2S4O6, sodium tetrathionate it is known as, right? Here let us find out what is the equivalent weight of sodium thiosulfate. If its molecular weight is M, equivalent weight is equal to, so let us balance this equation. This is 2Na, here we can put the quotient of this as a 2, right? Then for one molecule you consider, for 2 sodium atoms oxidation state is plus 2, right? For 3 oxygens it is minus 6. Then for 2 sulfurs it is plus 4, right? When we consider 2 molecules, then for the sulfur oxidation state for 4 sulfurs it is plus 8, right? Plus 8. Here in the sodium tetrathionate, oxidation state for the 2 sodiums is plus 2. 6 oxygens minus 2 is a general oxidation state. Minus 2 into 6 is minus 12. Then for 4 sulfurs, oxidation state is plus 10, right? For 4 sulfurs, plus 8 to plus 10 it is going, means it is losing 2 electrons. Students, here equivalent weight we need to calculate for only one molecule of sodium thiosulfate. For 2 molecules, the number of electrons lost is 2 electrons, right? For one molecule of sodium thiosulfate, number of electrons lost is 1. So that is the same as a N factor. N factor is equal to 1. So equivalent weight for the sodium thiosulfate, if its molecular weight is M, divided by 1. That means equivalent weight is the same as a molecular weight. Let us take one more example, disproportionation reaction. Students, next we will take one example, disproportionation. Disproportionation reaction we will take. Disproportionation is nothing but same element is undergoing both oxidation and reduction, right? So Br2 in the alkaline medium, it is undergoing disproportionation, which gives BrO3 minus plus Br minus. If the molecular weight of Br2 is M, what is the equivalent weight? So Br2 elemental state oxidation state is 0. Br minus oxidation state is minus 1, right? So decrease in oxidation state is reduction. This is a reduction process. Decrease in oxidation state is reduction. So in this compound, what is the oxidation state of Br? We know general oxidation state for the oxygen is -2. -2 into 3 is -6. Then for the bromine it is +5. +5 -6 we will get the same as the charge on the ion -1, right? So the oxidation state of bromine is +5. So 0 to +5. Increase in oxidation state, that is called as a oxidation. Increase in oxidation state is called as a oxidation, right? So students, the number of electrons transferred in the reduction process, number of electron transferred, assume that as n1. Here for 1 Br it is -1. If it is a 2 Br minus it is present, because in this Br2 we have 2 bromine atoms, right? So then we need to calculate for the 2 Br minus, then the oxidation state will be -2, right, for 2 Br. So N1 is equal to 2. How many atoms are there in this particular molecule? For that many atoms we need to calculate that, right? So similarly for here BrO3 minus +5, it is for the 1 bromine. For 2 bromines +10, right? +10. Then in the oxidation process, let us assume that that number of electron transferred is N2, that is 10 we are getting, because in the required molecule, what is the equivalent weight of Br2 we need to calculate. In this we have 2 bromine atoms, so in this also we have to calculate for the 2 bromine atoms, right? Then the n factor formula for the disproportionation is n1 multiplied by n2 divided by n1 plus n2, right? So substitute these values here. N factor we will get it as n factor is equal to n1 multiplied by n2 is 10 into 2 divided by 10 plus 2, which is 20 divided by 12. 4 5s are 4 3s are. N factor is 5 by 3 we are getting. So equivalent weight of Br2 is equal to, if the molecular weight is m, divided by n factor is 5 by 3. So bottom fraction will be reversed. Then we will get equivalent weight is equal to 3m by 5, right? This is the end of the chapter, students. Some basic concepts of chemistry which I have covered in the 2 lectures. In the next part we will discuss some questions once total chapters is completed. So again we will start the chapter number 1 with the questions. Thanks for watching.